Calculation example 6. In this example, again, it's an exam style question. We've got a teacher who believes the performance of students is affected by their age within the year group. So you may sometimes hear on the news people talking about summer births and how being born towards the end of the academic year in July or August is a disadvantage academically. So the teacher believes this is true, and so they've selected 50 students from year 11, and they've recorded the number of days between the start of the school year and each student's birthday. So the start of the school year is 1st September generally, and so if a student was born in October, that would be quite a low number. That would be something like 30 or 40. Whereas if you were born in July, you're getting on towards a year later, so D might be something like 300 in that case. He then calculated a score for each student's GCSEs, awarding 8 points for an A star, down to 1 point for a G. And he summarised his data as follows. So we've already got the data, we don't need to do all the adding up, which is helpful. So first thing we need to do is work out SXX. Now, in this example, X is actually D. That's the explanatory variable. The number of points in the GCSE is the response. So what we're assuming here is that the number of days after the school year affects the GCSE point score. So this one would go on the x-axis and S would go on the y-axis. So instead of writing SXX, I'm going to write SDD because in this case that's the variable. So it's sum of D squared minus sum of D all squared over N. Sum of D squared is 2202950, and then sum of D squared, and I think we had 50 students. And if we work that out, large numbers here, so I'd definitely be saving them in the calculator. The second one is S, not YY, but SS, so we've got 3 S's there. So it's the sum of S squared minus sigma S squared over N. And then if we sub the values in, 130752 minus sum of S squared, that's a 7 there, over 50. And if we work that out, 27148.48. Final one, it would be SDS. D is X and S is Y. So we've got sigma ds minus sigma d sigma s over n, and if we work that out, 401082 minus 2276 multiplied by 9294 over 50. And if we work that out, minus 21980.88. And again, save those in your calculator. So to work out R on the top, I'd have S ds divided by square root of S dd S SS. So on the top, minus 21980.88 divided by, this is going to be long, isn't it? Big numbers. 475381.28 multiplied by 27148.48. So sorting all that lot out on the calculator, I think works out to be minus 0.913. So check that you can get that. It says comment on the teacher's hypothesis. Well, not only is this number very small, virtually zero, very, very small. I wouldn't say that's evidence of a correlation, really. It's also negative, so actually it is very slightly the reverse. You would expect that as the number of days increases, the number of points increases, but actually this is the other way around. As the number of days after the beginning of September increases, we actually expect the number of points they get in the GCSEs to go down. So the teacher's hypothesis is kind of in the right direction because it's negative. However, there's so little correlation there that I wouldn't say there's sufficient evidence here. So we would expect it to be negative, but I would expect it to be minus 0.7 or so to make it convincing. So I would say here, very little correlation. It's virtually zero. So there is no evidence the teacher is correct. Notice how I've used that phrase, there's no evidence. Just on a sample of 50, you can't say definitely whether it's true or not true. But here, we can say that there is no evidence that it is true based on this sample.